All right. Today let's look at many examples, as much as possible on resultant and resolution of vectors. So you see the first question there. It says that two forces whose resultant is 100 Newton are perpendicular to each other. If one of them makes an angle of 60 degrees with the resultant, calculate their magnitudes. All right, that should be x after the magnitude. Their magnitude. So we're asked to find the magnitude of the forces, the two forces. Resolution of vector simply means to bring out the components of the vector, that's the horizontal and the vertical. And one thing you must know that is the vertical is always associated with the sine of the angle, while the horizontal is associated with the cosine of the angle. So do watch the video if you don't know that already, so you can really understand what's going on here. So let's go on and start solving right away. So you say that these two forces are perpendicular to each other. It simply means that they are at 90 degrees. So let's just put for them just represent something. Let's say we have a force like this. The other one should be in this direction, right? And they should be at 90 degrees to each other. So we can go ahead and say, okay, let's call this y, and let's call this x. We don't know the forces. So since they are forces, it's going to be in Newton. So y Newton, x Newton. And then they are 90 degrees. So this is what the question is saying. I said that their resultant is 100 Newton. Of course, you know that the resultant is in this direction. All right? So that will be the resultant. So the resultant, the value was given as 100 Newton. Now, it says if one of them makes an angle. Now, it didn't specify the one. It said just one of them. So let's decide that it is x that makes an angle. So the angle S makes with the resultant 100 Newton is 60 degrees. So this is what we have basically. The question I said calculate their magnitudes. Well, you know that x is in the horizontal direction. So the horizontal is also associated with cosine. So I'm going to say that the magnitude of S Newton will be equal to the resultant 100 Newton times the cosine of 60 degrees. While the other force, which is Y Newton, will be associated with sine since it's in the vertical direction. So it's going to be 100 Newton sine 60 degrees. Well, so if you know your trigonometric ratios and then you know Pythagoras theorem, this will be very simple. I have a video on all these things, so that's why I'm not taking my time to explain how these things are working exactly. So I'll put all these videos in the description. Just click on more, you'll get all the videos so you can really understand what's going on. All right, so at this point we can simply plug these values inside our calculator. 100 Newton times cos 60. Well, but we know that cos 60 is 1 over 2, right? So we know this is going to be 100 times 1 over 2, which is 50. So the first force, which is the S Newton, is 50 Newton, while the second one is 100 sine 60. Well, we know that sine 60 is root 3 over 2. So this is 100 times root 3 over 2. So we can cancel out there. So you see that 2 can cancel. 2 here is 1. 2 into 100 is 50. So the other force, which is Y Newton, is 50 root 3 Newton. This leaving it in a radical form. But we can change it because if we multiply 50 times root 3 with our calculator, we're going to get approximately to 1 dp now, 86.6 Newton. So these are the forces, 50 Newton and 86.6 Newton. Next one says that a boy is pulling a load of 150 Newton. So with a string, okay, let me just read more. With a string inclined at an angle of 30 degrees to the horizontal. I always like to draw my horizontal ground first. Alright, so I can begin to build upon that. So we have the floor, which I'm denoting with that, and then the load. So let's just use a box to represent the load. Say this 150 Newton. And then he's pulling this load, which is this box, with a string. So attach a rope. Basically, a string means a rope. But this rope is at an angle of 30 degrees to the horizontal, that our horizontal ground. So this is the picture of this question. But it says that the tension, that means the force, when you apply force with a rope or a string, is called tension. So the force on the string is 150 Newton. So this is 105 Newton. 150 is the force on the load, right? Or rather is the load itself. So it says what is the force tending to lift the load off the ground? You know that the force tending to lift, because if we resolve this 105 Newton, which is the force is applying, You see that that force is the resultant force. This force is applying, this 105 Newton force is doing two things at the same time. Is it is taking this ball, rather it is taking the load upwards, because that's the direction. It's taking this load upwards, that's for the vertical component, and is also taking it this direction, that's the horizontal component. So if we're asking the force that is tending to lift the load off the ground is the vertical component, right? And you know that the vertical component is always associated with sine. So simple is going to be the resultant force, which is 105 Newton, times sine 30 degrees. And that's it. Since they ask us to find the force that will lift the load off the ground. That would be the vertical component. So our answer would be 105 times sine 30 is 1 over 2. So basically 105 divided by 2. 2 into 10 is 5. 2 into 5 is 2. Remember 1, that would be 52.5 Newton. So this is the force that is tending to lift the load off the ground.